Okay, so this one, these are going to be chapter 17, and on page 360. And here we're going to be calculating the milliliters per hour flow rate for these drips and round the answer to the 10th. So we're titrating dosages according to patient response. So let's do number 1 here. And for this one again, solving for milliliters per hour and rounding to the 10th. So number 1, a provider orders argatroban IV drip to begin at 2 micrograms per kilogram per minute. 2 micrograms per kilogram per minute. The maximum dose is 10. So I'm going to go ahead and write here max dose 10 micrograms per kilogram per minute. The patient weighs 88 kilograms. And the IV bag contains 250 milligrams of argatroban in 250 milliliters. So 250 milligrams in 250 milliliters. So again, solving for milliliters per hour. So for these, we really want to know our ranges. So ultimately, you have to do, in these particular problems, solve for a range from our 2 in this case to 10. So I'm actually going to plug in our numbers based on both of those. So I'm going to have 2 problems here, but I'm going to start both of them with milliliters because I'm solving for milliliters per hour. Here's a sentence, here's a sentence, here's a sentence, and here's a sentence. So I'm looking for my milliliters per hour, or excuse me, I'm looking for milliliters in my information, and I have 250 milliliters equal 250 milligrams. If this is milligrams, I need milligrams here. And I go back up here, and I've got my other information is in micrograms. So I need to change this. 1 milligram is equivalent to 1,000 micrograms. If this is micrograms, we have to have micrograms here. And then I'm going to start with my lowest number, my 2 micrograms per kilogram. If this is kilograms, I have to have kilograms here. I'm going to plug in my 88 kilograms, and then just going to go ahead and finish up my minute here to finish out my milligram or micrograms per kilogram per minute. And if this is minutes and I need hours, I need to do my conversion, because if this is minutes, I have to have minutes here, and I need to go to hours, so I know there are 60 minutes in 1 hour. Milligrams would be canceled out, micrograms would cancel out, kilograms would cancel out, minutes would cancel out, leaving us with milliliters per hour. So 250 times 1 times 2 times 88 times 60 is 2,640,000 over 250 times 1,000, 250,000. So 2,640,000 divided by 250,000 gives us 10.56, and I need to round to the 10th. So that's going to be 10.6 milliliters per hour. That's for our 2 micrograms per kilogram per minute. Now, I need to know a range because this is my max dose, and so I need to know ultimately if when we start our drip that I know I can keep my milliliters per hour between X and Z, whatever. So you can do this a couple of different ways. You can go ahead and write all of this out, or I'm just going to change my 2 micrograms per kilogram here, and I'm going to add 10 micrograms. I hope that makes sense. So now I just don't have that 2 micrograms in there, and now have 10. So now I'm going to do 250 times 10 times 88 times 60, and that gives me 13,200,000. And then I'm going to divide it over the same number, so 250,000, and that gives me 52.8 milliliters per hour. So my range for a patient having 2 micrograms per kilogram per minute to 10 micrograms per kilogram per minute and them weighing 88 kilograms with this strength of our drug would give us 10.6 to 52.8 milliliters per hour. Okay, now let's do we'll go ahead and do number 6 on the same page, 360. So on this one we have calculate the micrograms per minute. Dosage currently infusing for these IV drips. Indicate whether the dosage is within the prescribed range. Within is ultimately what we want to know, or not. And round the answer to the nearest tenth. So for number 6, it says a diltiazem drip, IV drip is infusing at 9.8 milliliters per hour. The IV bag contains 100 milligrams of diltiazem in 100 milliliters. The prescribed dosage range is 84 to 167 micrograms per minute. And again, we're solving for micrograms per minute. This is our range, so we don't really need to do anything with that right now. We only need that at the end to figure out if our dosage up here is within this range. So I'm going to be solving for micrograms per minute, so I need to start with micrograms on top. Here's a sentence we're going to use. Here's a sentence we're going to use. And this is what we're going to compare that to figure out if we're within range or not. So do we have micrograms available in our sentences? We have milligrams. So we need to do a conversion from micrograms to milligrams. And I know that there are 1,000 micrograms in 1 milligram. If this is milligrams, milligrams has to come next. So that's where I plug in my 100 milligrams per 100 milliliters. If this is milliliters, milliliters has to come next. So here's where I would plug in my 9.8 milliliters per hour. And we want minutes. That's not minutes. So I need to do hours. If that's hours, hours has to go here, and I need to convert that to minutes. And I know in 1 hour there are 60 minutes. So now leaving us with being able to mark out our milligrams, our milliliters, our hours, leaving us with micrograms per minute. So 1,000 times 100 times 9.8 gives us 980,000 over 1 times 100 times 60. That gives us 6,000. So 980,000 divided by 6,000 gives us 163.3 repeating, and that gives us 163.3 micrograms per minute. And now I want to see if this is within our safe range. So now I'm looking up here at my range of 84 to 167, and does this fall within that range? Yes, so it is within.